Good day, learners. My name is Dr. Olutayo, course lecturer for CSA 312, Introduction to Formal Language and Automata Theory. Now, we shall be looking at section 1, and at the end of this session, we should be able to, the learners should be able to understand what's called alphabet, string, and representation. Now, introduction. The ability to represent information is crucial to communication and processing information. Human society created spoken English to communicate on a basic level and develop written to reach a more sophisticated level. The English language, for instance, in a spoken form, relies on some finite set of basic sounds as a set of primitives. The words are defined in terms of finite sequences of sounds. Sentences are derived from finite sequences. The written English uses some finite set of symbols as a set of primitives. The words are defined by finite sequences of symbols. Sentences are derived from finite sequences of words. Paragraphs are obtained from finite sequences of sentences, and so forth. Similar approaches have been developed also for representing elements of other sets. For instance, the natural number can be represented by finite sequences of decimal digits. Computations, like natural languages, are expected to deal with information in its most general form. Consequently, computations functions as manipulators of integers, graph programs, and many other kinds of entities. However, in reality, computations only manipulate strings of symbols that represent objects. The learning outcome for this session: 1. When you have studied this session, you should be able to define what alphabet, words, and strings are, state the basic relationship among these terms, state and describe the various operations that can be carried out on these structures, describe how they can be represented. Now, alphabet. What are alphabets? In computer science and formal language, an alphabet or vocabulary is a finite set of symbols or letters, e.g., characters or digits. The most common alphabet is 0, 1. That's the binary alphabet. A finite string is a finite sequence of letters from an alphabet. For instance, a binary string is a string drawn from the alphabet 0, 1. An infinite sequence of letters may be constructed from elements of an alphabet as well. Now, given an alphabet notation, which is in form of sigma, to denote the set of all finite string over the alphabet. Here, the notation star operator, which is the representation of the alphabet, to denote the set of all infinite sequences over an alphabet E. Now, for example, if we use the binary alphabet 0, 1, that is the string generated by the alphabet, the empty string 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, and so on, will all be in the clean closure of the alphabet, where E represents the empty string, which is actually part of the alphabet. Now, note that alphabets are important in the use of formal languages, automata, and semi-automata. In most cases, for defining instances of automata, such as deterministic finite automata, that is DFA, it is required to specify an alphabet from which the input string for the automation are built. Now, string. Also, in formal languages, which are used in mathematical logic and theoretical computer science, a string is a finite sequence of symbols that are chosen from a set of alphabet. In computer programming, a string is essentially a sequence of characters. A string is generally understood as data type, storing a sequence of data values, usually bytes, in which elements usually stand for characters according to a character encoding, which differentiates it from the more general array type. Now, in this context, the terms binary string and byte string are used to suggest string which stored data does not necessarily represent text. A variable declared to have a string data type usually causes storage to be allocated in memory that is capable of holding some predetermined number of symbols. Now, we want to look at some of the example. Let E be an alphabet. A non-empty string element of E are called symbols or character. A string over E is any final sequence of character, any type of character from E. For example, if E is representing 0, 1, then 0, 1, 0, 1 is a string over E. So that's the length of a string in the number of character in the string. The length of the sequence and can be any non-negative integer. The empty string is the unique string over E of length 0. So empty string always have a length of 0, which is denoted as E or lambda, as the case may be. Now, the set of all string over E of a length n is denoted by En. For example, if the alphabet E is equal to 0, 1, then E2 will be equal to 0, 0, 0, 1, 1, 0, and so on. Note that E0, which is empty for any alphabet, the set of all string over E of any length is usually called clean closure of E and is denoted by E star. A set of string over E, that is any subject of E star, is called a formal language over E. For example, if E is equal to 0, 1, the set of string with an even number of zeros will be first what E 1, 0, 0, 1, 1, 0, 0, 1, and so on. Is a formal language over E. Now, the set of all non-empty string of elements of V is denoted by V plus. That is another set of closure, which we usually have as V plus, which is but when E is equal to E, then V plus is equal to V star. That is, V plus means that it starts from 0 with non-empty. So it does not contain non-empty set. So 0, 1 plus will not have 0, 1, 0, 0, 0, 1. But when we have E 0, 1 plus, which is 0, 1 star, that is, this one will contain empty string, which will now start from E 0, 1, 0, 0, 0, 1, 1, 0, and so on. Now, the alphabet of a string is a list of all the letters that occur in a particular string. If S is a string, its alphabet is denoted by alpha S. String substitution. Let I be a language and let E be its alphabet. A string substitution is, or simply a substitution, is a mapping F that maps letter in E to languages. Now, concatenation and substring. These are part of the terminologies that are actually in line with formal language. Now, concatenation is an important binary operation on E star. For any two string X and T in E star, their concatenation is defined as the sequence of character in X followed by the sequence of character in T and is denoted by ST. For example, if alphabet is equal to AB to Z, which we can now equate as probably S is beer, T is og, then ST is beer og, and TS is og beer. That's the concatenation. Also, we have what we call substring. A string S is said to be a substring or factor of T if there exists possibly empty string U and V such that T is equal to U S V. The relation is a substring defined a partial order on E star, the least element of which the empty string. Now, we equally have representation. Similarly, if F1 is a binary representation over 01 of the natural number. And if f1, if f is 10, then you now have 00, 000, and so on. Similarly, f2 is a binary representation over 01 of natural number if it assigned to the ith natural number of the set consisting of the ith canonical smallest binary string in each case. Now, the summary of the study session. String concatenation is an associative but non-communicative operation. A string A is said to be substring or factor of T if there exists possibly empty string U and V such that T is equal to U S V. And a representation or encoding over an alphabet it of a set D is a function of F from D to 2E that satisfies the following condition. Thank you for listening. Thank you for